How did the universe come to existence? It's a question with many different ideas and theories, and people's interpretations can be different based on scientific evidence, personal beliefs, and even technology available at the time. Let's look at one of the most widely accepted scientific beliefs, the Big Bang.
So what is the Big Bang?
Let's go back about 13.8 billion years ago. The Big Bang theory suggests that everything space, time, and energy may have been packed into an extremely small, dense point.
Then boom! The Big Bang. But not an explosion in space. Space itself began to expand, like a balloon inflating.
As it expanded and cooled, tiny particles formed atoms. These atoms eventually made stars and galaxies, which are still moving apart, just like dots on a balloon as it stretches.
And the universe is still expanding today. How do we know?
Scientists point to something called redshift. In the 1920s, Edwin Hubble observed that galaxies were moving away from us. He used the Doppler effect, the same idea as a siren changing pitch as it drives by, but instead of sound, it applies to light.
Think of light waves like a slinky. If a galaxy is moving away, it's like pulling the slinky apart. The waves get stretched and longer. That's redshift.
This suggests that space itself is expanding based on how the galaxies are moving apart, just like the balloon.
One way we know that the early universe was hot is the cosmic microwave background, a faint glow left over from when the universe was much younger. You can think of it as a baby picture of the universe.
The radiation comes from a time when the universe was cooled enough for light to travel freely through space.
The orange represents the early universe, which was dense and full of particles. At first, it's covered in fog, like this plaster graph that scattered light. Let me do that again. When light tries to pass through, it's blocked and scattered. But when the universe cooled, the fog lifted, like removing the plastic, and light was finally able to travel freely.
That light is still out there, and we can measure it. It backs up the idea that the universe was originally hot and dense.
Is it filming? Another clue pointing to the Big Bang is the amount of light elements, like hydrogen, helium, and a bit of lithium we find in space.
Scientists predict that just before the Big Bang, the universe was hot and dense, enough to fuse these elements in specific ratios. And when we measure them today, those predictions were right.
This process is called nucleosynthesis. It's how the first elements were created in the early universe. When we look around the universe today, the cake matches the recipe perfectly.